So we kind of talked about this, and whenever you core something out, you're essentially removing a couple sides and leaving it hollow. So if we were going to core this out or shell it and remove sides, that's the same thing. So I'm going to use the shell command here, and I'm going to use a wall thickness. This is in millimeters. So when we're talking about wall thicknesses, I'm going to make this 3 millimeters. So how thick is that in inches? 1/8 of an inch. 3 times 40 thousandths is 0.12. That's, and you can look at the different materials to find out, but we're just going to use that as a rule of thumb here. So I'm going to go 3 millimeters, and we can put draft in as we're shelling something. We can add rounds on internal edges as we're shelling something. So, speaking of which, if we're going to do that, I don't really think that we want a bunch of rounds in this. I don't think we want a ton of rounds. Internal rounds would be good because that's where your steel is. But putting those internal rounds, if you shell it and then put your round in, let me think. You want to put your rounds in before you shell it so that the exterior is the round plus whatever, right? So we'll do some automated rounds, and I'm going to show you how to do that. Auto round the features. This one will add rounds to all exposed areas. So maybe we get internal and external here. This is new since I've used this. So we're going to go to placement and sketch. Now what is this? This is a rib. So no wonder that isn't working right. Get this thing off. How do I turn this off? So let's go over here. We need to do this one. Alright, now we don't have that option. Okay, 3 millimeters. We're going to look at that. So it's hollowing everything out. And we were saying that this is 10 inches, so it wouldn't be good to hollow it all the way 10 inches down. Plus we have some interfering features for our steel. The references that we might want to remove might be this outside surface and this surface. The reason that we would have to remove this one is we couldn't pull the steel from underneath here. So if we did that, what we're going to end up with is this open space, and we can stiffen this up by putting ribs back into it. So let's go ahead and say OK. Now you can shell one way, you can thicken by shelling the other way, and that's it. Let's look at options. You can exclude surfaces to be shelled, but it's going to have some difficulty. So sometimes these are difficult. Extend inner surfaces, surface extensions, convex and concave corners. Alright, so let's go ahead and look at that. And if you just hit the eyeglass, not the check mark, you can kind of see what it's going to look like after the fact. It's not too bad yet. So one question was, when we were previewing it, it looked like these two surfaces were overlapping. And then you might get some weirdness, and now it's gone away, but it looked like a sliver, and sometimes those are surfaces that just don't make. But let's go back and look at it this way. This is the way that you were seeing it, right? So the overlap. Right there looks bad, doesn't it? So this is where we might exclude one area from being shelled or have to go back and fill it in. These knife edges are not good. But we want to look at it with draft first, because that may eliminate our problem. So let's go ahead and say OK on that. This is also very sharp, but I see what you're going for is this cross section right down in here. I'm going to show you a way to use a cross section through your part and just drag it through your part to find any slivers. Alright, so we're going to go to View Manager, Cross Section, and I'm going to have it be New, whatever the name I want, and I'm just going to have it be planar and single, and I'm going to have, no, I'm sorry, let's quit this. Let's make a new one. And I'm going to make this one offset. One side. Single. And I'm going to make a plane here. and make it offset that way, default. So what is an offset cross section? I picked the wrong kind of cross section. I picked an offset, but really what I want is a datum that's offset. So I'm going to go back up here and create a new cross section, name it whatever. Planar, single, not an offset one, it's still going to be planar. And I'm going to make a datum, offset, a surface or another datum. And it asks for a value. If you do not enter a point, or it'll be fixed there, but if you enter a value of whatever, just hit enter and say done. Now if I right click on this, or if I double click on it, it makes it cut the part away. So I can literally turn around and look through my part as it cuts through it. And the way that we do that is we use a dynamic edit on the dimension, but instead of grabbing the datum plane, grab this box. We can cut all the way back and see where we're going to have issues. Right there is where we have issues. And it was really good that we saw that earlier so that we didn't have this knife edge of steel. So we have to figure out how to remedy this situation. One thing is we could have ribs that come up and actually take on this angle, right? If we need this surface, we could have ribs that come up and take on this surface as well. So we may want to shell this surface out as well. We just have to remember to come back in and make sure that we make ribs up to that surface, you know, that remake that surface. One thing that I like to do is make an assembly of both parts, the shelled and the unshelled part, and make sure that I have my ribs come up to those same surfaces. So I'm replicating that part, but I'm still coring it out. So the other thing that was said is we could have shelled this a 0.5 millimeter wider, but it would have had to have been the width of both of these walls. So that would have been about 1/4 inch. So we want to really watch that, and we may have to go back in and replicate this surface by putting in ribs. So let's go ahead and change this shell. And if I edit the definition of this, and then I hold down Control and remove this one as well. That looks a lot better. So now let's grab this and use a dynamic edit on here. Let's go ahead and pull this back and forth and make sure we're still good. You may want to turn around and do it different directions. All that looks pretty good. So now this is what we call coring a part out. So there was already someone saw a problem that we're going to have. So let's do our draft check. Anytime you core anything out, go ahead and draft check it again and make sure that you got everything that you can get. Solid geometry, select that. Direction will be one of these planes, and we've got a problem right here. Everything on purple should be from the underside. So we've got a problem already right here. So what do you guys think that we should do about this one? So the suggestion was to remove this side with the shell as well, put ribs back in there, and if we put ribs all the way across here to create this surface, we would be creating the surface as well. We'll just tie them together. You know, we can tie them together in another way, but the ribs that are tied together need to be in the pull direction. Alright, very good. So once again, let's go back into the shell, edit the definition, and remove this top wall. Because that really does make some weirdness right here, right? So what if we remove this wall right here from the shell? Is there any way that we could have had this come on over here without? Let's look at it. At the definition, is there any way that we could have done that? I don't see a way. You guys see a way? We would have a problem right here. Oh, you mean this way? Okay, hold on. So, two suggestions. We could leave this wall and core this from this side. That would make us not have to have any draft right here. So that would be a slide that slid out this way. That would retain this wall. Let me turn this on annotation. That would retain this wall and no draft here, so we would maintain our wall thickness here, on the outside at least. Still have to be drafted on the inside. And then we could put ribs here. The other suggestion was go ahead and make another rib here that would be a profile rib that followed the same profile as this. So we may make all of those ribs would be that way, right? It would be a pattern of ribs like that. Alright, so what do you guys think we should do? Depending on the way that the part is used, once again, that's really what matters, right?
I like the pattern of ribs.
Pattern of ribs across here, and then just leave the surface open. Okay, so let's just make a decision and go a direction, and that way we're really gonna just all be on the same path. So really, your suggestions are great. The slide is great. We're just going to make it cheaper doing it this way, and hopefully, you know, this isn't a surface that is necessary. So there's one thing that we wanted to talk about is maybe the order of operation of the shell. Should we draft some of these surfaces before we shell it?
I don't think it will matter ultimately.
No, because when you shell it, you get some new surfaces that need to be drafted, but in the opposite direction.
Okay, so if this were drafted this way,
Oh, I guess.
this would be drafted this way.
Okay, I'm thinking more about the rounds, but yeah, that'd probably work too.
It really helps.
And if we draft before we shell it, we'll have continuous wall thickness.
Yes.
More stuff.
Yes. If you draft before you shell, you get better continuous thickness of your wall. So that is it. That's it in a nutshell. So we're going to go ahead and draft before we shell on this one.